Levels of the universe and the Andromeda. Question. In this video, I'm going to tell you what keeps us trapped inside our own galaxy. Let's begin. Shall we go to Andromeda now? People sometimes ask, do you think one day we'll travel to other galaxies? It sounds cool when you hear it, I admit. But whenever I hear that question, one scene always appears in my mind. Someone dropping a single drop of water into the ocean and claiming they swam. Because the distance between galaxies is so extreme that even imagining we could go is already a surreal event. All right then, let's dig into the reason together. Let's explain it scientifically and melt our brains a little. First, what is a light year? Why can't the human mind handle these numbers? Andromeda is 2.5 million light-years away from where we are. This number looks innocent on its own, doesn't it? But a light-year isn't a measure of time. It's a distance. A light-year is the distance light travels in 1 year, moving at 300,000 kilometers per second without ever stopping. This adds up to about 9.5 trillion kilometers. So 2.5 million light-years equals 24 quintillion kilometers. That's 24 followed by 18 zeros. The reason the human mind can't comprehend this is simple. Our brains didn't evolve for numbers like these. The human brain's measurement scale is more like, how long does it take to walk to school? So, how long would it take to reach Andromeda? With humanity's fastest vehicle. Let's look at the fastest human-made spacecraft, NASA's Parker Solar Probe. It travels at roughly 700,000 kilometers per hour. At that speed, you could circle Earth in 3 minutes. Impressive, yes. But if you tried to reach Andromeda at that speed, it would take 4 trillion years. Trillion. Earth itself is only 4.5 billion years old. The universe is 13.8 billion. So if we calculate when the fastest human spacecraft would arrive, the picture becomes absurd. The universe would be born and die 300 times, and you'd still be on your way. What if we reached 10% of light speed? Let's assume we haven't broken physics, but we've pushed technology to the extreme. Imagine we built a ship that travels at 10% of the speed of light. That's 30,000 kilometers per second. Even at this speed, reaching Andromeda would take 25 million years. To put that in perspective, what existed on Earth 25 million years ago? Not humans. Even the earliest human-like apes were only just starting to appear. If those beings had built a ship and launched it back then, it still wouldn't have reached Andromeda today. And what if we reached the speed of light? Physics says never. Okay, let's just reach the speed of light. Sounds great, but the universe won't allow it. Why? Because as we accelerate, our mass increases. At the speed of light, our mass becomes infinite. And what do you need to accelerate something with infinite mass? Infinite energy. Infinite energy might look cute on paper. In reality, it's zero. Warp, wormholes, and sci-fi ideas. Warp drives in science fiction don't actually outrun light. They bend and shape space, shortening the path. Sounds logical, but here's the problem. The required energy is more than an entire galaxy produces. Wormholes? Mathematically possible. Physically non-existent. And even if one did exist, it would collapse instantly. Anything trying to pass through would be turned into spaghetti. So scientists discuss these ideas with excitement, but for now, all of them remain on paper. Now let's discuss whether space travel itself is even feasible. Space travel isn't as clean as we think. Let's imagine we somehow managed it. We built an insanely fast spaceship. Do the problems end there? No. Traveling through space is far more dangerous than we imagine. You'd face deadly radiation. Temperatures jumping from -100 to +100 degrees. Dust particles, yes, simple dust, hitting your ship like bullets. And we still need to think about food, oxygen, and an entire ecosystem for millions of years. So intergalactic travel isn't just far in distance, it's a logistical nightmare. A ship capable of doing this would need to be the size of a city and house hundreds of generations. Andromeda is already coming toward us. Here's the strange part. We can't reach Andromeda, but Andromeda is coming to us. It's approaching us at an extra 400,000 kilometers per hour. In around 4 to 5 billion years, the two galaxies will collide. The name is already set, Andromeda. The sky will look unbelievably beautiful. But by then, the sun will be old. Earth likely won't be habitable. And humanity? Will we be there? Uncertain. Let's wrap up by looking at our connection to the universe. All these numbers, all these calculations show one thing. Intergalactic travel, for now, is impossible. In fact, very impossible. But that's not where the beauty lies. The truly beautiful part is this. When we look at Andromeda right now, we're seeing light that began its journey 2.5 million years ago. That light set out long before humans even existed, and right now, it's entering your eyes. This is the most real connection we have with the universe. Maybe we can't travel there, maybe we can't reach it or go to it, but we can see it, and we can try to understand it. And I think that alone is an achievement for humanity.